Hello and welcome to this programming tutorial. In today's tutorial we're going to look at something called recursion. So what is recursion? Essentially recursion is a subroutine that calls itself. There are three different conditions we need to think about with recursion. A base case, the stopping condition, and we need to ensure that the stopping condition is reachable after a finite amount of times. So what does this mean in practice? Well, let's develop a subroutine called counter that keeps counting up until it gets to 9 or 10. In this example, we could use iteration, but let's see what it looks like with recursion. We'll define a counter subroutine. Let's call in count over here, which you remember starts at 0. And we'll say if count is greater than 9, we're going to return counts. So as soon as count is greater than 9, i.e. 10, it'll return 10. Else, we're going to do something else. I will leave it as pass for now while I explain or try out this subroutine. If I run the subroutine at the moment, I get nothing. This is because count is not greater than 9 and it doesn't return anything after. So let's modify this, and instead of doing count plus 1, because remember we could do count plus 1, except this wouldn't actually work. The reason it wouldn't work is because as soon as this runs, the subroutine stops. We need to somehow get this to repeat. Now you could put the entire thing in a while loop or in a for loop, but we could also use recursion here. Why don't I return the counter of count plus 1? So what is this doing? Well, count will start at 0. Then it returns the counter. So it's going to return the counter, which is going to be 0 plus 1, which is 1. Then that's going to return the counter, because remember, every single time count is below 9, it's going to return the counter of whatever the counter currently is, plus 1. So the next one will be 1 plus 1, which is 2. And then it will be 2 plus 1, which is 3. And it will keep going all in all the way up to it gets to 9 plus 1, which equals 10. Then it returns 10, which returns 9, which returns 8, and so on and so on and so on. This will return 3, so that means that this turns into 3. Sorry, this returns 3, which returns 2, which returns 1, and so on. So if I run this program now, I get 10, because it's going to keep recursing until this base condition, this base case, is met. So here I have a base case, my stopping condition, and my my recursion will be reachable after a finite amount of times. I know for sure that at some point count plus 1 is going to be greater than 9. So in this case, I've met the 3 conditions I should have for my recursive subroutine. Let's look at another example. Let's look at a factorial of a number. A factorial of a number, like 5 factorial, this is the notation to write a factorial number, is when you have that number multiplied by every number before it up to 1. The factorial of 3, for example, is going to be 3 times 2 times 1, which is 6. Now, how do we write a recursive subroutine for this? Well, first and foremost, let's look for a pattern here. What is our pattern? Our factorial pattern is we've got n times n minus, or n times n minus 1. This is our pattern over here. We've got 5 times, 4 times, 3 times. The reason I'm saying that is because we've got 5 times n minus 1, which is 4 times n minus 1, which is 3 times n minus 1. And keep in mind, n is going to be 5, then 4, then 3. So the factorial of 3, for example, is going to be 3 times 3 minus 1, which then becomes 2 times 2 minus 1, which then becomes 1 by itself. Because remember, 1 is technically going to be our base case because we stop at 1. So this returns 1. That means that this turns into 1. This is now 2. That returns over here as 2. And this is 3 times 2, which gives us the answer 6. Notice how that worked. we kept recursing until we reached 1. And then this one, I'll repeat myself here, returns here. This answer then returns here. And that gives us the last answer, which is 6. Now, how do we write this? Let's do the printout of factorial of 5. I'll define the subroutine up here. First and foremost, I need my base case. Now, this doesn't have to be at the top. You can have multiple base cases. You can have them anywhere in the subroutine. But in this example, I'm going to have the base case first. What is my base case here? My base case is when n reaches 1. So here I'm going to write if n is equal to 1. Now, when n reaches 1, what do I want to do? Well, if you remember from our example before, I'm going to return just 1. Because I'm not going to multiply 1 by anything, I'm just going to return 1. Else, we're going to do n times the factorial of n minus 1. And this we're going to return. So we are returning whatever n is times that factorial minus 1. So we're going to be doing this recursively all the way until it reaches its base case of 1. If I run this program, I get 120. Again, think about how the recursion works. We've got 5 times 4 factorial. And that's going to be 4 times 3 factorial. And that's going to be 3 times 2 factorial. That's going to be 2 times 1 factorial, which is just going to be 1. That's our base case over here, which is returning 1. So that returns over here. Then 2 times 1 is 2, so that returns over here. 3 times 2 is 6, that returns over here. 6 times 4 is 24, so that returns over here. And 5 times 24 is 120. Thank you for watching the tutorial. I hope you found it helpful.